Welcome to Calculus. Whatever confidence you have will be tested. But don't worry, Stevenson has tools to help you. On this episode, Stevenson will demonstrate
definite integrals have properties themselves. We've dealt with properties with many things we've studied over in mathematics. So here's a table of rules for definite integrals. The good thing I want you to know here is that we're only really going to focus on these 5. So you don't have to get 6 and 7 down. I mean, if you want to add them to your notes so you have them, that's fine, but we won't be studying them at this level. So I want to take a moment and just kind of talk about what each of these are telling you, and then I want to demonstrate how they work. Let's look at the first one. So this is the zero property or zero rule for definite integrals. So if you notice what this says that if you do a definite integral from a bounds from a to a, then it's 0. Now, that should make sense to you, because if the bounds are exactly the same, then there's no subinterval to find your area. So this says the area under this curve from a to a is 0. So hopefully that makes sense to you, right? There's no area. This next one works on addition, but what's really cool about this property is it reminds me of the transitive property we used in geometry when we would study or prove triangle congruence. So here's what I want to point out. You ready? This says the area or the integral of f of x dx from a to b plus the integral of f of x dx from b to c is the same as the integral of f of x dx from a to c. So look, where the first integral ends is where the next integral begins. So b is the link between a and c. So that's the transitive property. That's how I think of that, right? If a equals b, but b equals c, then a equals c kind of thing, right? That's where that idea is coming from. That's how I remember it. Maybe it'll help you, maybe it won't. But that's the second property. Let's look at the next one. Order of integration. This one comes in very handy. What this tells you is that you can switch the order of your integration anytime you want, but just make it a negative in front. Okay, and so if you think about what that does is it switches the bounds of integration. Well, the bounds of integration are your interval in which you're integrating over, or what do you find in the area under. So whenever you want to switch the bounds of integration, just make sure you put a negative in front of your integral. The next one's the constant multiple rule. We've had that before with derivatives, and it also applies to integrals. So if you notice here, what this says is if you do an integral, okay, of some function and there's a coefficient of any form in front of your function, you can move it out front and then still do your integral like you normally would. See any number k. The same thing applies with negatives. Suppose you have a negative in front of your function and you're doing your integral, you can move the negative out front and then apply your rules that you're trying to find your definite integral with. The last one here is sum and difference. So what this says is if you have the integral of a sum of functions or a difference of functions, you can split them up as a sum or difference of their individual integrals. Now, things to remember is that they each get their own dx, and notice the bounds of integration must be the same as the original part.